2-6 combinations of functions, composite functions, day 3 and 4. Your learning goal is that you will be able to build functions that model relationships between quantities from existing functions. In this lesson, we're going to look at the composition of functions, and we're going to learn how to compose two functions. And the symbol for composition looks like this. F compose G of x, which is the same thing as f g of x. Or you can see it this way. G compose f of x, which is the same thing as g f of x. And what that means is, for the first one, you're going to take the g function and plug that into the f function. So g is your input and fg of x is your output. So instead of plugging in an exact number, you're actually going to plug into the whole function. Now, when you do your domain, for fg of x, that means that, and I always like to write it both ways, that means that x has to be in the domain of g of x, and then g of x has to be in the domain of f. So when you're checking for domain, you still remember to look for those two things. It's negative infinity to positive infinity, unless you see division by 0, or the even root of a negative number. So when you're checking for that, you're going to check G first, and then make sure that G of X, that domain is in F. Okay, example 1, we're going to find each of the following. We're going to do F compose G, G compose F, and F compose G with an actual value of 2. So we're going to call the first one example 1A. So they're going to give you two functions. For example, let's say that f of x was 4 minus x, and g of x is 2x squared plus x plus 5. Okay, so first we're going to do little a, which is f compose g of x. So that means that you're going to take the g function, because I'm going to rewrite it. You're going to take g of x, which is 2x squared plus x plus 5, and you're going to plug that into the f function. So if you notice, f of x is 4 minus x. So you're going to replace this x with this part right here. So it'll be 4 minus 2x squared plus x plus 5. So that's going to give us 4 minus 2x squared minus x minus 5. Combining like terms, our final answer, or simplified, would be negative 2x squared minus x minus 1. So basically what you're doing is you're taking two functions and you're composing them into one. All right, let's do little b. We're going to do g compose f, which is the same thing as g f of x. Okay, my g, excuse me, my f, because you always start inside. You do the inside first. So f of x was 4 minus x. So what you're going to do is you're going to plug in that 4 minus x in for x in the g function. So you're going to have 2x squared plus x plus 5. So everywhere I see an x, I'm going to replace it with 4 minus x. Okay, the part that students mess up on because they forget that you have to FOIL this. So this will be 16 minus 8x plus x squared plus 4 minus x plus 5. And I'm going to distribute 32 minus 16x plus 2x squared plus 4 minus x plus 5. Then from here, you just combine like terms. And I'm going to get 2x squared minus 17x. And that'll be plus 41. Then part C. Let me stay consistent with my colors. We're going to do F compose G, and we're going to plug in an actual number for X, which is 2. So that means F of G of 2. So that means that we're going to plug in 2 for our G function. And just to remind you, our G function was 2x squared plus x plus 5. So we're going to plug in 2 everywhere we see an x. Because remember, you always do the inside part first. And do an order of operations. That's 8 plus 2 plus 5. So that answer is 15. So now we're doing f of 15. Because g of 2, because remember now this was g of 2. So that answer was 15. So my f function, remember, was 4 minus x. So that means wherever you see an x, you're going to plug in 15. 4 minus 15 is negative 11. So that's your answer. So you always go inside out. Example 2, we're going to find f compose g, and then we're going to find the domain. So I've given you f of x and g of x. So we're going to find f compose g of x, which is the same thing as f of g of x. So f or g of x is 6 over x. So that means in your problem of f of x, your function, everywhere you see an x, you're going to replace it with 6 over x. So that means on the top, you're going to have 6 over x. This x now becomes 6 over x. And then you still have the plus 5. Now, we can't leave all those fractions over fractions, so what I'm going to do is multiply everything by x. So that those x's can cancel. And then you'll be left with 6 over 6 plus 5x. Okay? Now we're going to find the domain. When you do the domain, first you have to find the domain of the inside. So remember g of x was 6 over x. And you check your two things you're looking for. Do you see square roots? No. Do you see a fraction? Yes. What would make this denominator 0? Well, x equals 0 has to be excluded. Okay? Then you find the domain of the entire thing, which is f g of x, which we found to be 6 over 6 plus 5x. Same thing. Do you see a square root or an even root? No. Do you see a fraction? Yes. We have to figure out what would make this denominator 0. So I'm going to subtract 6, divide, and that number has to be excluded from our domain. So when you write your final domain, that means on your number line, here's negative infinity, here's infinity, negative 6 over 5, and 0. So we can use everything to the left, can't use that one. Everything in the middle, can't use 0. And everything larger than 0. So to write it in interval notation, it would be negative infinity to negative 6 over 5, union negative 6 over 5 to 0, union 0 to infinity. So when you do your domain, you have to check the inside and then the outside, or the final. Okay, our last example, example 2b, we're doing the same thing. We're going to find f composed g, and then we're going to find the domain. This time, I want f of x to be x squared plus 1, and I want g of x to be 2 minus x. So the first thing we're going to do is find f compose g, which is the same thing as f g of x. Okay, so g of x is the square root of 2 minus x. So what that means is in my function f, everywhere I see an x, I'm going to plug in 2 minus x. So that's squared plus 1. Well, when you square a square root, it goes away. So that's left with 2 minus x and then the plus 1. And then if you combine like terms, you're going to get 3 minus x. So that is f g of x. Okay, so our final is 3 minus x. Okay, to find the domain. So first we have to find the domain of g of x. And this one, we do have a square root. So we have to figure out what values of x can I plug in to make this non-negative. So you're going to do 2 minus x is greater than or equal to 0. I'm going to subtract 2. I have to divide by a negative, so this inequality has to flip. So this means we got to use all the numbers smaller than or equal to 2, including only. So only this side. So this domain would be negative infinity to 2 with a bracket because it's included. So 2 is included. And then the domain of our final answer, which was fg of x, which is 3 minus x. Okay, do you see any square roots? No. Do you see any fractions? No. So this domain would be negative infinity to positive infinity. So now I have to figure out of these two domains, which domain would basically take care of both functions. Well, we definitely cannot use the second domain because this square root cannot use anything larger than 2, so it won't work, which means we will have to go with the first domain. So you have to make sure that your domain, you write this so you know, my final domain is negative infinity to 2. Make sure that your final domain would satisfy both functions.